Okay, so today we are going to continue working on our third-person shooter prototype. Our focus today is going to be on getting our character movement going. So right now, as of last class, we had our camera orbiting our player. Our camera is not clipping through walls, which is nice. Doesn't go through the floor, but we need to get some character movement going. And I had a little bit of a change of heart. We were going to use rigid bodies, but we haven't played with them yet. So I figured it would be good to show you guys. We're going to use the character controller component in Unity today, which I know Braden might kind of cringe at. It's another way of moving characters around. The character controller is a little bit weird. It's sort of like a fake physics system. So rather than using a rigid body and using add force or setting velocity directly, we can use this character controller that acts like a rigid body in terms of we can move it through code, but it doesn't interact with the physics engine. So it doesn't accelerate with gravity. It doesn't push things around. It can't get shoved or knocked around, which depending on the game you're making can be a good or bad thing. But it does simplify a lot of character movement stuff, which I can kind of explain as we get into it. So we're going to be using that to set up our characters today. And we're going to be kind of forward thinking, and we are going to set up this character movement. So it'll be kind of agnostic in terms of how it's controlled. So we're going to use the same character movement script or component for both our character movement and then with our AI that we're going to add in our next class next week. So with that being said, unless we have any immediate questions or concerns, we can get started. Cool. Okay, so right now we have our YBot character here. All we have attached to it is an animator.
I have a question.
Oh, yeah, what's up?
What would you say is more common, like to use rigid bodies or to use a character controller? Or does it depend on the game?
It kind of depends on the game. They're both used quite a bit.
Okay.
The one time I would say you'd probably 100% use a rigid body is if your character really needs to interact with physics. So if you're doing something goofy, if you've ever played like Gang Beasts, which is a like physics kind of brawler game, that is definitely rigid body. If you are doing something where maybe your character, just because it comes up a lot in student projects, maybe your character, you want to set it up so your character swings on like a rope or Spider-Man or something like that, that you would definitely want to take advantage of all the joint and spring systems in Unity. So you use a rigid body for that. Outside of that, especially games that don't have a lot of complex movement, like if you're doing, I don't know, maybe a game like StarCraft, like an RTS game, or like a top-down kind of RPG like Diablo or something like that, you'd probably just use a character controller because your character doesn't really need to interact with physics in the same way as sort of a full-on rigid body.
Nice. Okay, thanks.
Yeah. Okay. So let's go and on our character here. Oh, actually, I'll show you guys something I like to do. So often when I set up characters in Unity, I don't like having the character directly as the root of my object. It makes it hard to swap out art. If I want to basically swap this character out with new art, I've got all these objects that are already a child, basically, of this structure. It's all part of the character. It can be annoying to swap out either the mesh we're using or maybe do kind of changes at runtime if you want to make the character look different. So we'll kind of recreate a new character here. So let's just go and hit the plus, and we're going to create a capsule. Now, what's kind of interesting about the character controller is it's basically a movement system and collision combined. You can add additional stuff to it if you want more messages. So we'll actually set that up so we can take advantage of that if we want to. You don't really require a collider or a rigid body on a character controller to get it to bump into stuff and get collision messages. So on this capsule, we already have art for our character. So I'm going to remove the mesh renderer. So right click and remove that. And I'm going to remove the mesh filter as well. And one thing you'll notice about this capsule here is that our pivot, if I hit Z, I make sure this button says pivot, our pivot's right in the middle of the character, which I don't like. When I position a character, I like its basically 0, 0, 0 position to be flat on the floor. So I want to make sure that that pivot is always kind of in between the character's feet. It's the same thing when you guys learn to make characters in game art. You always want the pivot of that character in between their feet. So if we just sort of zero everything and stick them together, everything's going to be lined up correctly. So over on the capsule collider, we can adjust the center value. So it says center X, Y, Z. I'm just going to put a 1 into the Y value. See if I zoom in here. My pivot is now at the bottom of the capsule. So when I kind of drop it down like this, there we go. That's where it'll sit.
Can you do it again?
Yeah. Oh, sorry, I'm getting messages popping up. So yeah, just on the capsule, the center value, I want to change the Y to 1.
Like moving the pivot more? That was more my question. Just
Yeah,
press Z?
that moved the pivot. Just change. Oh, yeah, that. So if you just have the capsule selected and hit Z, it'll just move the pivot back and forth between the center and the actual pivot position. So when we've got that there, just so we get kind of all of the messages we probably want out of Unity, if we want to get like on collision enter, stuff like that, the character controller has its own callbacks that we'll use to detect collision. But we can get the standard physics ones as well. So we'll leave the capsule collider attached, and then I'm going to put a rigid body on there. The difference here is we're not going to be using the rigid body to drive the character at all. So I'm going to, it's kind of unnecessary, but I'm going to turn off gravity because we don't need it on. And I'm going to set the rigid body to kinematic. So when it's set to kinematic, it's basically an immovable object. It will interact with physics. Things can collide with it, but it is never going to move on its own for any reason.
So we're still using a rigid body component?
Yeah, we're still using it for the physics callbacks, but we're not going to be using any, on our code side, we're not going to be touching the rigid body at all.
I see. Okay.
And yeah, all we have to do is check off is kinematic, and we don't need to adjust anything else on our rigid body. Okay, so we've got that. The third component is our character controller. You'll notice the character controller has a bunch of values we can tune. So similar to the capsule, the first thing I want to do is adjust the center value. So you can actually see if I move it up, it's kind of weird. It's put the character controller, that's it down here, kind of this size. It's the same size as our capsule, but it's down below. So I'm going to adjust it. And just like our capsule collider, I'm going to change the center to 0, 1, 0. I'm just going to put the capsule collider and the character controller on top of each other. Now, there are some other values on the character controller here, and we can play with them more later. But it has some cool features. So the slope limit will determine what kind of slope the character controller can move up. If we have it set to something low, like 15, it can go up slight slopes, and then we'll stop if it hits something kind of steep. So 45 is a pretty steep slope. We'll play around with that at first. If it's not enough to make it up our little ramp here, we can adjust it. The step offset's really cool. So most rigid bodies, if you hit a small ledge, you have to kind of bump up onto it. The step offset will basically automatically detect small steps like stairs or a curb or something like that, and allow the character controller to just basically hop immediately up on top and keep moving without slowing down a whole lot. So it's a nice feature for handling stairs or other small kind of bumps. The skin width and min move distance both relate to how basically the character controller handles bumping into stuff and moving around. So the skin width will basically allow the character controller to kind of push slightly into, if these are sort of two surfaces colliding, they can kind of push into each other a little bit without immediately colliding, and it helps prevent a little bit of jitter as it touches other surfaces. The min move distance will make sure that if you put in a movement amount smaller than that very small amount right now, the 0.001, it's not going to move the character, it'll just stay still. So it's not like slowly drifting in a particular direction. And then the center, radius, and height basically operate exactly like the capsule collider. So what I like to do once I get those set up is we can adjust this after, but I'll put the new capsule kind of where the character is. And I'm going to parent the Y-bot here to the capsule. And then I'm going to change its position to 0, 0, 0. So if we look at it, my Y-bot character is now at 0, 0, 0, centered on the pivot of our parent capsule object. And the cool thing about this setup is I often end up creating a standard character prefab in my games. And then when I load a character in, rather than having a full prefab with all the character stuff and the art attached together, ready to go, I'll often have a separate prefab. And my character spawner will go, okay, I'm spawning a character. It's going to spawn the capsule. And then it goes, which art are we using? And it's going to spawn the Y-bot and attach it to the capsule for me. And then my character's ready to go. So if I want to make some sweeping change to all the characters in my game, kind of how they operate, I don't need to adjust the art prefab of every character in my game, just that main one character prefab. We're going to be a little bit lazy in this project and leave them as one prefab, but that's kind of one of the reasons why I do this. Okay, the other adjustment I want to make, just because this capsule is currently pretty huge compared to the character, is we could lower the radius of both the capsule collider and the character controller to maybe 0.3, shrink it a little bit. And there we go. That fits the character a little bit better. I was watching, there's a new Warhammer 40K game that just came out on Steam. Can't remember the name of it now. It's based on one of their old tabletops, but it's basically like a turn-based tactics game. And I was watching, I don't know what they did with the navigation of the character collision in it, but I saw this one guy was trying to move between two of his own units, and they were like several feet apart. You could see there was like a clear path between them, and his own character wouldn't move in between the other characters. He kept like bumping into some invisible geo, and then he had to like walk all the way around his own teammates to like continue moving on past his own characters. It was really weird. You don't want to end up in that scenario. Okay, I'm also going to rename this object to character for now. Now, if you guys remember from the last class, we had set up our camera controller. So if we hit play now, it's still going to work, but our camera controller is currently pointed at our character art and not the character root itself. So I just want to make sure that on our main camera here, our third-person camera controller, I want to make sure the anchor is my new character root object instead of the ybot. It's not much of a difference right now. I just want to make sure it's pointed at the correct object.
Sorry, anchor, which one?
So on your main camera, you have your third-person camera controller.
Yes.
The anchor slot here, just make sure your character is dropped in there. Originally, it was the ybot.
Okay.
We don't want it pointed directly at the art. Should look like that. Okay. So we have our 3 components here. We're going to worry about things like navigation in our next class. So all we need to do now is start working on adding our character movement. And then we're hopefully going to have enough time to look at animation later today too. So let's go and add a new script in our scripts folder. And I'm going to call this character movement. The reason why I call this character movement is I like to make it a little bit more specific. In that it is movement for what I consider a character, like a basically biped humanoid. You might have different movement scripts for different objects in your game, for maybe 4-legged creatures or for vehicles or something that's flying. So I just want to make sure they're differentiated. So I usually, for my humanoid type characters, I call it character movement.
Gonna make it so that we can change it quickly to AI movement as well. That's what you mean?
So the not necessarily. So the AI controller is going to handle kind of its movement outside of the character movement class. The character movement will take care of just movement itself without any sort of AI logic going. But what I like to do, if I'm going to have kind of different movement modes, like say you have a character hop into a vehicle in a game, you would probably have a base movement script that can take input from the player, and then the exact type of character movement, or sorry, the exact type of movement will handle that input. So if I say have a character movement script set up, my forwards and back input would move me forwards and back, and my left and right would move me left and right. But say my character hops into a vehicle, I would still have my controller pointed at a movement class, which is now a vehicle movement instead of a character movement. My forwards and back will make me move forwards and back. My left and right will make me turn if I'm moving. So you can kind of handle that input differently by just inheriting and subclassing.
I have a question. Like every time I press by mistake on the game window, I lose my mouse.
It locks in. Yeah, we're gonna fix that right now. It's bothering me too. So let's just right click and open C# project. Let's go, and we are kind of done testing the camera, I'd say. So I'm first going to go and open up our third-person camera controller script. And I'm going to comment out the execute and edit mode so it stops doing that.
It's still doing that, like, and I removed it already.
Could be because it's already executed once. I don't think we're calling it anywhere else. Yeah, no, we're not. I bet. Oh, that is weird. It's still doing it on mine too. Huh. I'm gonna try restarting Unity.
I was just about to Google if that was a requirement.
For me, it showed that it's loading the lights, so it probably didn't render the rest of the code. Like, I stopped the light and now it's works.
Yeah. Oh, okay. Yeah, after commenting that out, I just restarted Unity, and that will stop it too. It's interesting that changing scenes didn't stop it. Oh, actually, I bet if you commented it out and then hit play, and then stop playing, it would have done it too.
there a quick build button for Unity? I know it's supposed to do it automatically.
What to build lighting?
Not like to render like the code if it didn't do it already.
Oh, I don't think there's a way to force it to recompile. You can re-import assets. Sometimes refresh will do it, but not really. Honestly, if you needed to like force it to recompile, changing your code will force a recompile, but it didn't do anything after we recompiled the first time, so it probably wouldn't help in that scenario. Okay, so we're going to work on our character movement. This class is going to get a little bit complex, but we're going to start off pretty simple and kind of slowly add features to it. So let's go and add a bunch of, we're going to add some headers and then a bunch of values to our character movement class. So up at the top, I'm going to add a header and just call this, let's call this movement. We're going to add a bunch of float values. So I'm going to have a max speed, set that to be 5. Does anyone remember the hotkey to duplicate a line?
Control D.
No.
Is it Shift Alt then down arrow?
Yes. So hold down Shift and Alt, and you can just keep hitting down, and you'll make duplicates of that line. So we have to do a few floats, so it'll be useful here. So we'll do max speed, and we'll do, I'm going to change this to, and I'll leave it at 5. I'm good with that. Change it to acceleration. It's going to have a turn speed that we'll get in there eventually. We'll add in some more details later. Add another header called airborne. This will handle all of our in the air stuff. Now, character controllers can handle gravity for us, but I'm not a big fan of that. I like to set up my own customizable gravity. I'm going to put in a gravity value. I also find often in games, sort of realistic gravity doesn't feel very good. We're used to like kind of the Mario style, like pretty quick up and down kind of jumping, which isn't too realistic. If we were to throw ourselves in a few meters in the air comparatively, and then wait to fall, it would kind of take a while. Where in games, it's usually much, much faster than real life. So I usually crank up the gravity quite a bit. And we'll also have a jump height. And finally, some air control. So these are all fairly self-explanatory, I think. Well, yeah, I think these are all fairly self-explanatory. I'm not going to bother commenting these values. We're going to add, oh, right, we need some components too. Just need the one right now. We're going to have our character controller. And that is the character controller component we added. We can just drop that in the inspector. And we're also going to use some properties. Oh, sorry, I'm getting messages from Chris. Okay. So we're going to use some properties to handle some values for us. So one of the really nice things with the character controller is that it handles an is grounded property for us, which we can kind of expose in our script. We're going to need it for things like the animation, so we can decide whether or not we are playing a falling animation. So I'm going to set a comment here. These are our properties. So we can create a public is grounded bool, and we'll use the little shorthand here to return character controller is grounded. And we're going to need some other values. We're going to have a public vector3 move input.
How is the character controller checking that it's grounded? The same way we did in the...
Yeah, it's pretty similar. I believe they use a raycast. Oh, that didn't work. I believe they do a raycast down because they also, the character controller will detect the angle of the surface you're trying to walk up. So I'm pretty sure they're doing a raycast and then figuring out the angle you have to walk up based off that. But it's basically all handled under the hood. You could add your own kind of grounding system if you wanted to. It's not a requirement that you have to use the character controller one, but it's pretty quick to use this one, so we'll use it today.
Does it know what to use for the ground? Because I don't see like a...
That's a good question. I'm going to show you an interesting bug, because no, it doesn't. Okay, so we're going to have a move input. We're also going to have a, so we're going to have a local move input that we're going to need for our animation system later on. So the local move input, just to explain the difference here. So our move input will be basically the direction in world space that we want to be moving. If we want to be moving sort of in the north direction, it's always going to point north. The local move input is going to be our move input in relation to our own orientation. So if we want to move north and we are facing north, it's going to be in front of us. If we want to move north and we're currently facing east, it's going to be to our left. So we can use that rather than the global move input. We can use the local move input to figure out which direction our feet need to be moving when we're strafing around in our animations. So we're going to use that there. We're also going to need a look direction. Since this is a third-person shooter, we're not necessarily going to be moving and looking in the same direction, so we can use that to orient our character correctly. Okay, I think that should be it for now. Oh, the final thing we need to add is our velocity. So I think I mentioned this maybe last class, but the character controller doesn't adhere to normal physics rules. It only moves when we call the move function on the character controller. And so we need to do a little bit of work on our own setting up the velocity of our character. If we need to have sort of like an acceleration, we need to be constantly modifying the velocity of our character to achieve that. So we're going to have a velocity value we're going to be adjusting to move our character around. Okay. So let's go and set up a couple of the functions we need to communicate with our character movement here. So we're going to set up functions that can be called either from our own, our player controller script here to handle movement on our character, or they can be called from our AI controller, which we're going to set up in our next class. So we want to be kind of agnostic there and not, I'm getting way too many messages. I'm closing everything, sorry. My friend is.
You could probably set yourself to busy in Discord. Then maybe they won't message you as well.
I'm just going to close it for now.
Fair.
That latest message was my friend telling me that Cheez-Its are apparently available in Canada. Not important. Okay. All right, so we're going to have two main functions that our player controller is going to use to interact with our character movement here. We'll add more for our AI in our next class, but for now we're going to have one to set our move input, so we can tell our character movement which direction we want to be moving. And then we're going to have a set look direction, so we can tell our character movement which direction we should be looking while we're moving in that aforementioned direction. Let's create a public void. I thought I closed Discord. Oh my God. Okay, public void set move input. It's going to take a vector3, which will be our input. Oh, this would actually be a good case to use an extension method, which I was asked about previously. So one thing we want to do on our set move input here is we want to make sure that if someone else is coming in and calling our code and doing something weird, like say they want to move up a slope, so they'll give like a move input that's in an up direction, which is kind of weird. We don't want our character doing that. We want to handle any sort of movement up or down a slope in the character movement itself. We want to make sure that our movement input coming in is flat. So we can write an extension method to take care of that. So let's go back to Unity really quick. Should compile. And I'm going to show you guys extension methods. So extension methods are really cool. They basically allow us to add additional functionality to existing classes like vector3, which is what we're going to use, that will kind of look like it was built into Unity. So even though we don't have access to that class in and of itself, we can still extend functionality on it. So let's go and create a new script. We're going to call it extension methods. The script doesn't have to be called this. This is sort of a standard thing people do, is they have a single class with a lot of their extension methods in it. You could have it, if you're writing a lot for a particular class, you could call it vector3 extension method, something like that. But we'll likely only write a couple. Now, this doesn't have to be a mono behavior. Actually, we don't want it to be a mono behavior. So I'm going to remove that. And I'm also going to make this class static. I don't think we've used a static class before, but this will, adding static to the class signature here, will make sure that everything in the class is static. We don't want any non-static stuff in this class. And then adding an extension method is really easy. I had a comment here. So this will flatten a vector3. So we're going to write it like this. Public vector3.
Public static.
Oops, yes, thank you. Public static vector3 flatten. And this is going to look kind of weird, the incoming parameters. So normally if we're operating on a vector3, it would look like vector3 vector, like that. What we're going to do is add, in the front of this parameter, we're going to say this, which looks kind of weird. But basically what it does is, rather than having to pass a parameter, so we don't need to go extension methods dot flatten and then pass a vector3 to it, we can take the vector3 we're working on and just call dot flatten, kind of like how you can call dot normalize or any of the other built-in vector3 functions. And all we're going to do in this function is pretty simple. We are going to return a new vector3 that has the vector.x and the vector.z, but we're just going to set y to 0 to basically flatten the vector. So these extensions and methods are really handy. You can add them to pretty much any classes you want within Unity to extend functionality without having to go through the process of decompiling the engine to add stuff to it. Okay.
I thought the character controller doesn't take into account the Y volume.
It does, because you can use the Y value in the character controller. So it does if you use one particular movement function. There's another one where it doesn't. There's basically one where it handles gravity for you and one where it does not. We're going to use the one where it doesn't. So we can actually use the Y value to send the character controller up when we do like a jump or do acceleration down for gravity. So the way we can use this extension method here is we can flatten our, incoming vector here. So we can call our vector3, we can do something like this, go flattened equals input dot flatten. And we're going to flatten it. And then just in case, again, we're kind of being defensive here and making sure nothing weird happens. Just in case someone gives us some really weird input that is outside of the normal range we're expecting. So we want our move input to have a magnitude of between 0 and 1. We don't want a negative magnitude. That doesn't make any sense. And we don't want a magnitude above 1. So we're going to do this all in one line, but we're going to go move input equals, and we're going to go vector3 dot clamp magnitude. And we're going to pass our flattened vector and our max length. So here we are making sure our flattened vector doesn't have a magnitude past 1, and then we're assigning it to our move input. We're going to be taking this move input and multiplying it by our max speed later on to get our target speed. And if we have a move input past 1, it will do weird stuff to our velocity and make our character move too fast.
With the extension methods, if we want to like overload it, it will be the same thing as overloading a normal method. If you want to like make it with another value or something.
Yes. Well, I'm trying to think. I've never really thought if I've overloaded an extension method before. Can't really think of a use case for that, but yeah, you can overload functions as normal. Okay, our next function, after we set our move input, is going to be to set our direction. Oh, I completed something weird. So we're going to set our look direction. And what we're going to do is, first, just going to add a little comment here. We're going to say ignore if no direction. So we're going to go if direction.magnitude is less than something really small, like 0.05, we're just going to return. Unity doesn't like it when you try and use an incredibly small vector, like one that's basically 0, to try and set a rotation. So we're just going to make sure if we're sending in no rotation, we're just going to ignore the value.
I have a question.
Yeah.
If we're using arms for our game, like where does the pivot have to be?
Oh, if like you're doing like a first person type game, sorry, the pivot on your character.
Yeah.
So what I would do is still have the pivot down below where the character's feet would be, and then have your arms kind of floating just up above, attached to the character.
Okay.
Or even some people do it just so the arms are always in front of the camera. They attach the arms directly to the camera, also works. So it doesn't matter where you look, you can still see, you know, the hand sticking out.
Nice. Okay, thanks.
Yep. Yeah, there's a lot of goofy stuff. I don't know if I could find it. First person stuff in games is always super weird. Let's see if I can find an example of it. I know people took some funny screenshots. Oh yeah, here we go. This is a perfect example. The frame rate might not be great, but this is in Crysis 2. So here's the first person view, basically going back and forth between the aim and crouch behind cover. And then the third person view does that. Since they have a game where you can always see your character's feet, the feet kind of remain normal, but they stretch out your torso and leave your arms and upper body intact as well, because you can see parts of that. Yeah. And then for if you're doing like, you know, local co-op or multiplayer or something like that, they would use a separate model for your character to show that stuff happening.
That's how we do it in real life.
Okay, so after we set the look direction, we can do something kind of fancy here. So we're going to ignore any really low values for the look direction. And we also want our look direction to, especially this one, to flatten, because if we are, you know, for some reason our player controller sends the input, we're trying to go up a ramp, we don't want our character to like lean back as they go up the ramp. So we want to make sure we flatten our look direction so the character's always just rotating this way, no matter the orientation of the ground below them. So we're going to go look direction equals that direction dot flatten dot normalized. We can call both the functions just in a chain there. The reason why we handle these differently is obviously for set move input, we might want a input of 0, because we don't want our character moving around when, you know, the person's not using the thumbstick or moving around with WASD. But the look direction, we always want to have some sort of magnitude coming in there, a standardized magnitude with length of 1. Since our look direction, you know, you don't really look harder or less hard in any direction in a game. And all of the functionality around turning a direction into a rotation is going to want a nice normalized value to play around with. So we'll normalize it as we set the value. That stuff we'll handle later. So the next step is to actually work on the movement of the character. So we're going to have we're going to have kind of 3 different sections. We're going to work on our basic movement today and our rotation. And then in our class next week, we're going to add in some stuff to handle pathing. So one of the reasons I like including pathing in all character movement is you want pathing obviously for AI. You don't want the AI kind of calculating paths and just driving movement through set move input. It's a lot easier for your AI to go, I'm going to go here, please go here, and just tell the character movement to do that. But then you'll also end up in scenarios where maybe you separate these two and go, okay, my character movement will always take a vector 3 for movement, and then my AI will just use a destination. So you end up writing 2 different movement modes. And then you get to the point where you want to add a cutscene to your game. You need to move your main character from A to B, the same way an AI would. And now you have to have like a third script to handle a character, your player character navigating from one point to another. It seems goofy. So we're going to have both functionality on both of them. Basically one nice master movement mode for everything in our game. Okay. So I'm going to break convention here, but where do we do our character movement normally?
Fixed update?
Yes, so that is for rigid bodies. The character controller doesn't interact with the physics engine in the same way. With a rigid body, we can add force or set velocity and then make sure our rigid body is interpolating so it moves nice and smooth in our game. With the character controller, you can drive it in fixed update, but it's going to be kind of choppy because it's going to update in the fixed update, which might not line up with our camera update. So for the character controller, we actually handle our movement in update instead.
I had my movement in update and it was super choppy, and then I moved it into fixed update and it started working correctly.
That's likely a sync
know.
issue between the camera and the movement.
Okay.
So probably what
Yeah.
was happening is your camera was, I forget, did you use Cinemachine for that?
Yeah.
Okay, so we can play around with that. Likely Cinemachine thought your character was moving using fixed update. So
Mhm.
it was updating on fixed update. So you had your character moving on update and it was causing this weird desync.
Yeah.
You usually want them kind of lined up.
Okay.
Or using something like the, where do we do it? There's camera controller, or using something like late update works well in that scenario. So that was likely Cinemachine
Problem.
messing up that sync.
Okay.
So
Yeah,
you might,
I think where that is, I'm gonna check it out because yeah, that makes sense. But what were you saying?
what was I saying? Yeah, I've had Cinemachine do that a few times.
Okay.
You can actually, I can show you guys, we're gonna do our second class of Unity tools is all gonna be all about Cinemachine and cinematics in Unity. It's gonna be another kind of low/no code class. But I can show you guys how to actually force Cinemachine to use one or the other. It by default uses this thing called Smart Update, where it tries to guess if it should be using update or fixed update, but you can actually just tell it which one you want it to use. Okay, so let's go, and I'm gonna add just a couple comments here to keep things organized. So I'm gonna add a placeholder one here for navigation, which we're gonna leave empty for now. Then we're gonna have, below that, we're gonna have movement. Below that, we are going to have our rotation. Okay, so movement, we're gonna go through a very similar process to how we set up our character movement in the 2D project we did at the end of Unity 1. So I really like that pattern. We're going to calculate our target velocity and get our current velocity and basically interpolate towards our target. So first we'll get our target velocity. And that's going to be our move input times our max speed. Now we've already handled everything with our move input. We've sanitized it, as you guys might have heard, used online for things like taking input from the user. That's basically what we're doing. We're making sure at this point we can guarantee there's nothing weird going on with our move input. We could get more complex later and add in a way to handle a difference between an acceleration and deceleration, but we're not going to worry about that now, so we'll skip it. But I do like to figure out our control value. So we're going to use this little pattern. So we already have our isGrounded value set up, which is perfect. So we're going to go control equals isGrounded. So we're saying here, based on this bool isGrounded, if it's true, we take the first value, which is going to be our normal movement. I'm going to be kind of lazy and hard code that. I don't see a position in which we would change the standard movement value, so I don't really feel the need to expose it in the inspector. But the second value is exposed, which is our error control. So we're saying our control value, if we're grounded, is 1. We have full control of our character. If we're not grounded, our control value is set to our error control, which is currently 0.1. So basically, we're going to accelerate more slowly in the air. So we can make minor adjustments to where our character is going to be landing, but we can't like do goofy stuff like in games I hate it, where you can like jump up in the air and then turn around and go back towards where you landed. This is very unrealistic and to me kind of over the top for air control type stuff. And then we need to do a lerp. Actually, have we talked about lerping and interpolation yet? But we might have done a little bit.
You may have mentioned it last term. I don't think we
So-
actually did a lerp though.
Lerping is linear interpolation.
Although Scott may have shown them a lerp, but I'm not
Yeah.
sure if that's true or not.
We did it a bit in Unreal.
Oh, okay, cool. So it's the same process in Unity. There are a lot of different ways of doing an interpolation. A linear interpolation goes from, here's a good example here. Basically goes from one value to another. This is this would be a vector 2 interpolation because we have an x and a y value. We're going to be interpolating 3 values because it's a vector 3. But basically we'll take 2 points, and based on a second value you give it, we'll pick a value somewhere along that linear line between the two. So if we give it, for this, we have x0 and y0, that is our A point, and then x1 and y1 is our B point. If we are interpolating from A to B, and in this case, it looks like it's in the middle, so this would be a value of 0.5, would result in this middle here. If we interpolate from A to B and give it a value of 0, we're just going to be at A. If we're interpolating from A to B and we give it a value of 1, it's going to be 100% of the way over, so it's going to be at B. Now, we can do some interesting stuff where if we interpolate, rather than using a fixed value and saying, you know, here, 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 we can interpolate by a small amount every frame, which is kind of interesting. Now, if you can picture this, say we are going to interpolate from A to B every frame our game runs by 5%. So we move forward, actually, let's say 10% to speed it up a little bit. So in our first frame, we go from A to B 10%, kind of like there. Now, we're now interpolating from this point. This is our new A. So when we interpolate again, we're going to interpolate 10%, which is now going to be a slightly shorter interpolation. So this is our new point. We're actually less than 20% of the way now. We're then going to interpolate a third time, and again, it's 10% of the remainder. So it's going to be a slightly smaller interpolation. And that's basically going to continue. So if we're interpolating by a small amount every frame, the further two values are from each other, the faster it's going to head towards them. As they get closer, it's going to slow down. So we get kind of a nice ease to it. So in this case, we're using it for our character acceleration. If we're trying to switch directions very quickly, we're going to rapidly kind of start heading in the new velocity, and then we're going to slowly meet that velocity as we get there. So it adds this kind of nice, more realistic ease if you can think about the way a character would move. If you plant your feet and kind of move in one direction, you'll move very quickly. But if you're trying to like get up to your full sprinting speed in a straight line, it's going to take you a while. So we can do this interpolation like this. We're going to go velocity equals vector3 dot lerp. And the interpolation function, just like we were kind of showing earlier, takes 3 values. It takes your original, your A value, and it takes your target, which is your B value. In this case, that's our target velocity. So we're going from our current velocity to our target velocity. And then we need to give it our step, basically our progress from A to B. what we're going to do here is we're going to take our time.delta time. We want to make sure that this is not frame dependent. If we ignored that, basically people with faster computers would accelerate faster than people with slower computers. And that obviously in an online game scenario or even in a single player game would cause some weird issues.
If we were, for example, were using the fixed update, we
Yeah.
would use the fixed delta time, right?
Yes, yeah. Although keep in mind, depending on how your math works, in fixed update, it runs at a very constant tick. So you don't even necessarily need to use the fixed or the fixed delta time if you don't need to. Then we're going to multiply this by our acceleration and finally our control value. So the faster our acceleration, the higher our acceleration value, the faster we're going to reach our target velocity. But it's also multiplied by our control. So if we're on the ground, we're going to accelerate faster than if we are in the air, which is using our air control value, which is at 0.1. So if we're airborne, we're going to accelerate or approach our target velocity at 10% of what we would normally. And it's 10 o'clock. We'll add one more line here. We're going to handle, actually I'll do this. So this is accelerates to target velocity. And we're also going to add gravity. Since our character controller, as I mentioned before, basically ignores the physics engine, we need to handle gravity ourselves. So after we do our initial interpolation towards our target velocity, I'm going to go velocity plus equals new vector 3. And we're going to make some assumptions about our game and say gravity is always down in the world. We're not doing any weird messing around with, orientation of the character. So we can just pass it a 0 for x and z, but our y value is going to be our gravity times our time.delta time. And just to point out, just to make sure this is correct, your gravity should be a negative value. If it's positive, your character is going to levitate rather than fall towards the ground.
Quick questions. Like
Yeah.
last class, I talked with you a bit about deceleration as well.
Yeah.
You will add it inside the velocity?
Yeah, we could actually do that later once we get our character moving. I can show you an example of that. It's very easy.
Thank you.
Okay, it's 10:02. Let's take a break. I will leave this code up. We'll start again at 10:12, where we'll continue working on our character movement here. Actually, before we go on break, does anyone have any questions?
Yeah, could you just repeat again why we cannot use fixed update with the character controller?
Oh, so we totally can. It's
Okay.
just that it's going to, so normally when we do physics movement using fixed update, let's go back to Unity to show you. We do all those operations in fixed update, and then we normally change this interpolate value from none to interpolate. So what that does is in between our physics, so if we have two physics kind of updates here and here, and we have our normal screen update happen in the middle, it will do an interpolation and actually, based on the velocity of the object, move the object to where it should be, so you avoid that stutter.
Okay.
With the character controller, you could actually try it if you want. You could change this to fixed update. With the character controller, we can't interpolate it in that way. So if we're running on fixed update, it skips that interpolation and it'll only update on fixed update. So you end up with a weird desync and it can stutter the character.
Oh, I see. Okay.
Yeah.
I see. Okay.
I have a question
you.
about like the submission for tomorrow.
Yeah.
How do you want us to submit it?
Oh,
You want us to
so
build it
sorry.
actually?
Sorry, we would like a build for you guys to present to us, but it's going to basically be a just quick presentation at the start of class.
Yep.
So nothing
So-
needs to be handed in on Moodle. We just need you guys to show us what you've basically got so far.
Yeah.
So
And
debug-
if things are split up onto different computers, different people could show it off at different times. That's totally
Yeah.
fine. Like, say, for example, you have like 2 main builds that each show off your mechanics. As a prototype, stuff being separated is fine. And say you have your art on another computer, then 3 people can present.
So if I have like all the debug system inside the inspector, I use the naughty attributes to make like button with like summoning boxes and pickups.
Yeah.
Do I need to make it inside the screen so we'll be able to debug from the game, from the build?
Ideally, yes.
Yeah, if you want to show that for tomorrow, that's all right. But yeah, you do need to get that stuff integrated into the game. We can actually, maybe we should do that. We could actually go over a bit of that in Team Project tomorrow. I can show you guys some simple ways to add a bunch of debug buttons to your game.
That'll be good.
Just faster to make it as in the inspector if you want.
Yeah,
it
I
in
mean,
the-
so the inspector debugging is really good, but being able to debug in a build is also really important.
Yeah, and to be honest, you can honestly use the same sort of more or less chunk of code and just separate what the inputs are coming from based on have a hash in editor only or whatever, then hash and build, etc. And then you can split off,
Yeah.
like if you're in a build, do this, like have this pop up instead, and if you're an editor, have it be entirely based on the inspector. It's very, very simple to do as well.
So you want me to add it to the build for tomorrow?
Yeah.
Cool.
I have a question about the lerp.
Yep.
How would it be different, or is it the same as having A over B and then multiplying it by the step value?
A over B. Yeah, that's going to end up, so that's going to take that's going to kind of average them. Yeah, I'm trying to think. So if you do A over B, I mean, I guess it will be kind of the same. Or would you have to, I think it would have to be B divided by A, not A over B.
Or the other way around?
Yeah, yeah.
Okay.
And then multiply by the step value. So you could do something like that, I guess. The one thing is it's going to be, I think it's going to be harder to make minor adjustments to that because you're going to end up in that scenario. I guess the one issue that could come up is obviously if you're at a 0 velocity, you can't divide by 0. You're going to get a not a number error. But also if it's just your initial velocity in that scenario is very small, your initial acceleration is going to be absolutely massive. So the numbers might end up kind of messed up where you it could be so high that your first tick, your first step in one frame is like several meters where your character basically teleports.
Oh, okay, but you would use the lerp to handle situations where you want to do that.
Yeah.
Okay, I was just having difficulty with that in my head.
Yeah.
Okay.
Okay, yeah, let's go on break until, I guess we've got a few more minutes, till 10:18, and then we will continue. So the character controller has 2 functions here. We can call character controller dot move or simple move. The difference here is the simple move basically, as you were saying earlier, will ignore the Y value and it'll apply gravity for you. The move function basically allows you to mess around with gravity and do stuff like jumping with the character controller. So that is the one we're going to be using. So all we have to do is call move with our velocity. Now, one thing to keep in mind, this isn't setting the velocity of the character controller, it's moving it by this amount. So we need to do a second multiplication by time dot delta time. So this is more like a rigid body .move type call, where it's expecting us to move it by a small amount every frame to get our character moving around. We can still add in some rotation stuff, but we'll worry about that afterwards. The big next step now is to actually set up our input coming from our player controller. Right now, our character movement is good to move in any particular direction we tell it to, but we don't have any input going into our character movement yet. Okay, so let's go over to our player controller. I'm assuming everyone has this copied down. We're good here? Hopefully.
Yeah.
Cool.
Yep.
Okay, so in our player controller, we're going to do this the wrong way first as an example. I'm going to show you guys what happens when we ignore directions when it comes to handling input. So we're going to add a new field here to our player controller. We're already sending input to our camera controller. We need to also send input to our new character movement script. So we're going to add that. We also need to add in our move input. And this is going to look basically exactly like our on look. So our input already has an on move input. So we can go input value, value, and set our move input to our value.get vector2. So we're taking our move input and assigning that to an input value. In update, we're going to take that value and send it to our character movement. Okay, so actually we're going to do this wrong twice in a row. So first, you figure the simple way of setting our input is we could take our character movement and go set move input and create a new vector3. Since our incoming input is vector2, we want this to be in obviously 3D space. Could go new vector3 and go move input dot x 0 and move input dot y. Something like that. We can try that out and see how it goes.
Isn't that last value supposed to be Z?
Yes,
Z?
it is. Thank you. Oh, wait. Sorry. No, that is Z. Remember, this is a vector2.
Oh, right. Yeah.
So it's X and Y. Yep. Okay. So we can test this out. Let that compile. So our character, we're going to have to do two things. Our character needs our character movement component, and then we need to plug the character movement component into our player controller so our player controller knows what it's controlling. So let's go and add directly onto our character. I'm going to add the character movement component. You'll see it has all of our stuff plugged in here. We've got our max speed, our acceleration, turn speed, gravity, everything's there. We just need to plug in our character controller so it knows which component it's sending messages to.
Is there a reason to do that and not get component inside the script?
So that is a good question. I've actually found myself for a long time, I would use basically get component as much as possible inside script and avoid doing stuff in the inspector. But I've come to realize that's kind of limiting in some scenarios. In this particular instance, there probably isn't much of a difference between them because we're probably not going to reconfigure it a lot. But for some things like the animation controller, we're going to point to a particular animator. And sometimes that animator is going to be part of the root of the object. Sometimes it's going to be a child. Sometimes it's going to be a few levels deep. I would rather expose this stuff in the inspector and plug them in manually so I could reconfigure things as I want without having to worry about where the get component call is coming from, just to add a little bit more flexibility to my scripts. But in this scenario, there isn't much of a difference. It's also
be better to do like in the start try get component. So if there is like a character controller, it will take it. Doesn't matter what you put inside. And if there isn't, like,
you could do that. Yeah, actually, you could do both. That's not a bad idea. Okay. So we plug that in, and then we need to make sure our character is plugged into our character movement field on our player controller. Once that's done, you can hit play, and you'll notice a bit of an issue. It doesn't matter where I point my camera, my character's moving in the same direction. Now, if you're doing a, just this really quick while we're running, say you're doing a Diablo style game and you have a little character in the center of your screen and your camera doesn't rotate, this is going to work just fine. Since your movement is probably kind of a world relative anyway. But obviously in our scenario, if I want to move forward and I press forward, I'm always going to be moving in the world forward direction, which is a bit of an issue because it's going to be kind of awkward to control our character here. Let's take a look at how we can fix that. Actually, before we continue, did anyone have any issues? Did anyone's not behave that way? Everyone should have their character moving.
Can I see the character like that?
Yep.
Not the script, the inspector one.
Yeah.
Thank you.
So these could actually be minimized. You just need the capsule collider. Actually, capsule collider and rigid body are kind of optional right now. You don't have to have those. You just need the character controller and the character movement.
Where is the component? Oh.
Right here.
Oh yeah.
So those two.
Yeah, I got it. Thank you.
Yep, it's working.
Mine is not, but on the console it says null reference exception.
Did you plug in your character controller?
Oh no, I have not.
So I'm likely going to show you guys this little plugin for Unity called Naughty Attributes. I think I mentioned it before. They have a really cool feature. You can add a little attribute to fields that you need to plug in, and it'll basically pop up this huge warning box with this like red triangle saying something has to be plugged into here or it's not going to work. It's great for stuff like that. And then as soon as you plug something in, it just hides itself and it looks nice.
I have a tendency, if I do serialized fields like that, I have a tendency to also put like if checks, like, hey, on awake, if this is null, just get it, because I don't really care.
Mm-hmm.
But yeah.
Yeah, you could kind of do both. I know sometimes I will put in like a null check. Like you could go in your character movement and say, if your character controller doesn't exist, don't call move. But I find that kind of more hides the problem, because then you're testing and your character doesn't move, and
Well,
there's nothing in the log. You have no idea why something's going wrong.
that's when you throw an error.
Yeah, that's when you put in a proper message and say, hey, dummy, you didn't plug in the character controller. If you can't figure this out, contact Quinn, kind of thing.
And then if you really don't trust people, you can slowly turn the screen pink. Everyone will understand something's wrong.
You can also put like in the debug log like message if it's null.
Yeah. So one thing.
Remember, not everyone looks at the console though.
Yeah.
But particularly a lot of designers, they will actually, like a lot of people, if they haven't messed around a lot in Unity, they'll actually have their console closed.
Yeah. Well,
So
yeah. To be fair, the default layout in Unity does not show the console.
Exactly.
It's really bad. I don't think we've actually done it, but you can actually. You could go if character controller equals null. So we've done debug.log. You can debug log error or warning. So you can just write a message that says, character movement is missing, character controller. And one thing that's cool about the debug messages that we haven't done either is there's a second parameter you can pass called the context. So if I put in game object as an example here, so that's this game object I'm referring to. If I remove this and I run, it's going to throw that error. I'll spam with the other ones. Wait, where's my error?
Oh, my guess is because of that error, maybe it's not even getting to that point because it's not checking.
That's very weird.
Maybe try throwing it on the awake. My guess is because you're trying to get it to the is grounded value.
Yeah.
The is grounded value is that.
Putting it first, yeah. Yeah, we can put this in start or awake. I just wanted to show you that second parameter thing. So if I have nothing selected in the hierarchy here,
There you go.
and it happens, so I'm currently in play mode. When I click on this message, you can actually see it ping the character. So it's letting me know which object the error is on, which is handy. Sometimes you get like an error in the log and it's kind of vague and you just have no idea what it's referring to in the scene.
Oh, a good habit though is as you guys go through your team projects, do get rid of extraneous debug logs.
Yes.
In the final projects, often, particularly it's an issue more with PGs than anything because I don't know why they seem to like a lot of debug logs.
Yeah.
But you'll end up combating with each other in terms of debug logs, and sometimes you'll see like 30 exclamation points and then a message and 30 exclamation points and stuff like that.
I did that on my final project. It was brutal. And you can just a second. So normally I get like a couple hundred frames per second. Let's see. Oh, let's see if I can kill my performance as an example. So normally I'm getting a few hundred frames per second. If I play now, getting 120 frames per second with all these messages. Let's go to 1,000. It might take a while to ramp up, but the more complex your strings are and the more you're writing, the more it's going to hurt your frame rate. So I just went down to 120 to 15 frames per second because of all the messages in my log.
Yeah. And you might not notice this because this will only ever happen in editor, but builds will work fine.
Yeah. Although, keep in mind, if you're using debug.log, there is a log file on your computer. I've seen some Unity games where devs haven't cleaned that up. And while it's not causing a huge performance hit, you go into the log and it's like 10,000 lines long after playing for an hour, just because they spam so many messages to the log.
Yeah. Largest file I've seen was 3,500,000 lines.
Oh my God.
Notepad++ could barely handle it.
Yeah.
It was a nightmare to have to dig through to figure out what was broken.
Okay. So going back to our movement here, this didn't work. We're stuck moving in world space, which we don't want. So we can go and set up our move input in this fashion. So we can go move input equals, so we can basically localize it in a few different ways. We can go and I kind of like this method. So I'm going to go and on the player controller, I'm going to take the camera controller dot transform dot forward times my move input dot y value and my camera controller dot transform dot right times my move input dot x. So we can try that and pass that move input. I'm going to break these into 2 lines. And whoops. This is going to put it in local space, but you'll find we still have an issue. Okay, so we have these values in here. Let's try testing them out and see how our movement feels now. So I'm going to move in the direction of the camera. But you'll notice an issue. It might be hard to tell on my screen, but it now uses the angle of the camera to determine our movement force. So moving left and right is always going to feel fine because we're never rotating our left and right orientation, but we can tip up and down. And the problem is that we are tipped down. Remember, we were taking that y value and flattening it. Most of our forward input is actually on the y-axis right now, going down. So when I move forward, I'm going to move very slowly. The more level I am, the faster I'm going to move until I'm moving at sort of my normal speed.
Do we need to flatten it?
Yeah, it's the
Somewhat?
same deal if we point up. So what we're going to do is we're actually going to do some vector math to solve this problem. So we haven't dealt with this before, but we're going to use the cross product to figure out the correct direction of our character. So we'll start off pretty simple with this. So what we need to do is our right direction is working. So we don't really need to worry about right. We already know which direction right is. But we need to figure out what the correct forward is. The good thing here is we already know, like I mentioned, a few of these values. So I'm going to, I'll leave that for now. We'll work up above here. So we already know, as we mentioned before, we are assuming that up is always up in our game. So I'm going to go vector3 up equals vector3 dot up. We also know our right vector. So we were looking at it, our right movement felt okay. We weren't rotating the camera. If you were rotating the camera like this, doing kind of a roll, it would mess around with that input, but we're not. So our right is equal to our camera controller dot transform dot right. The tricky part is figuring out our forward, since that is changing based on the pitch, yes, the pitch of our camera. So we can use something called the cross product. This is one of the two kind of big, important vector math functions you should understand as you work in code. I didn't learn cross product and dot product when I was a student. I really wish I did. It would have made my life so much easier in a lot of ways. But they are two very, very important mathematical functions. And they are mathematical functions outside of games. Any sort of 3D math, they're used in like engineering and all sorts of other sciences. Anytime you're dealing with 3D space and directions, they're very, very handy. And we can make it pretty simple by using our hands and looking really dumb as we're sitting at work. Have you ever seen a programmer doing this stuff and looking at their hands? They're doing a cross product operation. So Unity is what we call a left-handed system. Unreal is actually the opposite, but it means if we're doing the cross product, we want to use our left hand. It also means that if we are figuring out any sort of rotation, we use our left hand as well. Sort of a side note, if you're ever figuring out how you need to rotate in Unity, if you put your hand up with your thumb out and pretend your thumb is the forward direction on an axis. So for instance, say my thumb is the forward direction on the y-axis pointing up. It means the direction my fingers curl is going to be the rotation when I add a positive rotation. So when I increase y, I'm going to turn to the right because it's a left-handed system. Unreal is the opposite. It's a right-handed system, so your axes rotate in the other direction. If we go positive on the up axis, which is Z in Unreal, you're going to rotate counterclockwise rather than clockwise. Their cross product is also done with the right hand, but in Unity we use our left hand. And we have 3 values with the cross product formula. So the first, and I want everyone to follow along with me, look real dumb as you sit there in front of your computer, stick out your thumb, this is A in the cross product. Then stick out your pointer finger, this is B in the cross product. So we have A and B are our 2 inputs, pretty easy. The third one is our middle finger, which we're going to stick out. This is C, and this is the result of our cross product. So if our fingers kind of like this, they're all perpendicular to each other. And this is the way the cross product formula works. So you take 2 vectors, 2 directions, 2 vector 3s, and you get a resulting vector, a direction, that is perpendicular to both of those inputs. And we can do a lot of cool stuff with this. A big example that a lot of people use is figuring out mathematically if something is to the left or right of our character. So you can imagine if my character on screen here is pointing forward, we have our z-axis sticking out the front there, the blue one. If I point my thumb in the direction of the z-axis and then pretend my pointer finger is any other direction, we can use the resulting vector to figure out if something's to the left or the right. So I'm going to move back a little bit. So if I'm pointing this way with my thumb forward and my pointer finger is going to the left, my result is pointing down. So I know if the result is down, that object's to the left. If it was the other way around, so my thumb is pointing forward and my index finger is pointing to the right, my result is now pointing up. So we can actually just compare the y value of the resulting vector to figure out if something is to the left or the right of our character, which is kind of cool. It's really useful for having AI turn in the correct direction without having to do a whole bunch of other weird math. You can basically do it with one little quick check. What we're
Isn't there like a something already like local position inside Unity?
I'm not sure. There might be. I've always just used the cross product because it's fast and easy. Honestly, if they have something built in to figure out like a local left and right direction, it's likely just using the cross product under the hood. You could also write your own wrapper for that. Just like a quick little, I mean, you could do an extension method to figure out if like a point is to the left or right of a vector 3 kind of thing. What we're going to use it for is figuring out the forward direction of our character. So what we can do, since we know 2 vectors already, we know our up and our right, and we want them all to be perpendicular to each other, that allows us to figure out the forward direction of our character. So A is going to be our right direction, pointing to the right of our character. B, our index finger, is going to be up. We know that as well. And we know since the cross product always returns a value perpendicular to the other 2, our C, our index finger, the result, is always going to be pointing forward. It doesn't matter how we rotate this way. Since this is the only rotation we have is essentially this way, we're not aiming our character this way and doing weird stuff. We're always going to get the forward direction out of the cross product between those 2 values. So it's fairly simple on the code side. We can go vector 3 forward equals vector 3 dot cross. And we're going to give it, they say here the left-hand side and right-hand side. It's basically A and B. So you give your thumb first, then your index finger, and you get your middle finger out. So the first value is going to be our A, which is going to be our right. Second value, B, is our up. And that's going to return the forward vector pointing forward from our camera.
So if we want to get like the backwards back,
Yeah.
we need to like make one of those negative.
You could, or we've already figured out forward, so you could just use negative forward. But if you wanted to go back, yeah, you could go actually, you'd probably do is do negative right. So that basically pointed around the other way. So it's pointing, A is pointing left and up, and that would, yeah, give us backwards.
So it will work the same if we are using like forward and up. If we will always get the like to the right.
Yeah.
Unless we make one of them negative or make like
Yeah, then it would point to
negative
the
and
left.
then we'll.
Yeah.
Okay.
Yeah. Yeah, it's a really handy formula. And the nice thing about games programming is this is already built in. Unreal has a built-in cross-product formula. We don't need to know all the kind of handwritten math under the hood. You can learn that stuff if you want, but we have this function ready to go for us, so we can figure out the cross-product very quickly and easily. So all we need to do now is modify our existing little addition here to produce our move input. And we're going to use these values instead. So I'm going to plug my forward into here. Actually, I can do this in one line now. And our right into the camera controller.transform.right to replace that. And that is our new move input. Oh, while we're here, so we don't really have to come back, we could also go and add in our look direction. So we're going to be passing our look input both to our camera controller and to our character. The difference here is we're going to take our character movement, we're going to set our look direction and pass our camera controller.transform.forward. We always want to look in the forward direction that our camera is currently facing. You could do some fancy stuff and have, if you're not aiming, your character can rotate freely and you can look at the camera and stuff like that. But we're just going to set it up so our character always rotates to face the same direction as our camera.
One last question about the cross. It will always
Yeah.
return like the other two values as 0, right?
Yeah. Okay, has everyone copied this down? Okay with this? Cool. So now I can still move forward in the correct direction. I can move left and right. If I point straight down, I am still going to move forward at the correct velocity because we're always getting that forward vector. It's going to be pointing forward regardless of the pitch of our camera here. Cool. Is that not working for anyone? We're all good? Cool. So we're approaching 11, but let's see if we can get our jump in here before we have to go on break. So right now, we don't have a jump function on our character movement. We don't even have a jump input. So we're going to have to add both of those. So let's work from our input and work our way. Actually, no, I'm going to change my mind. We're going to work the other direction. We'll start off with our character movement. So we already have our jump height. We're actually going to do a little bit of fancy math here to figure out the velocity we need when we jump. So let's go, and after our set movement and set look direction, let's try adding a jump function. sometimes you guys remember from Unity 1, I call this try jump because you don't necessarily jump every time you hit the button. So you can kind of call it whatever you want. I'm just going to call it jump for now. This part is pretty simple. What we're going to do is if we are touching the ground, we're going to set the vertical velocity of the character. We go if is grounded. We're going to do all of our jump logic inside this if check. If we are not grounded, we are not going to do anything. Our character is going to sit where he is. And we're going to do something kind of weird here. We're going to set vertical velocity required to hit jump height. So this is actually kind of easier than it sounds. We can take our velocity .y, so that's our vertical velocity, and set it to a particular value. Now, we want to figure out how much velocity we need to reach a certain height. We can actually use our total jump height that we want, our gravity value, and a constant to figure that out. So the velocity required to reach our jump height is going to be equal to the square root of our jump height times our gravity. So obviously we need more force based on, obviously if we're trying to jump higher, we need more velocity. If we have more gravity, we also need more velocity because our gravity is going to be working against us moving up. And then we need to multiply it by -3. And we take the square root of all that and it returns that value. If you guys remember, this is actually based on like high school math. If you ever did the physics classes where you're trying to figure out stuff like, you know, Steven is throwing a shot put and it needs to go blah, blah, blah far and reach this height. You know, how much velocity does it need when it leaves his hand? It's the same formula. And we're going straight up and down, so it's a bit simpler. The -3 constant is just part of the formula. The reason why it's -3 is, remember, our gravity value is negative. So if we were to put this, we would actually launch the character down rather than up.
3 is a specific number? It's not like
Yeah, it's just a constant that's used in this formula. I think that's actually a rough estimate. I don't think it's the exact value, but it does a pretty good job of getting our character to the correct height.
If we wanted to have a double tap to jump higher, how would you check for a double tap?
So what I would do, I mean, you could do a double tap. You can actually do that in the input manager. We can look at that in a second.
That'd be good.
Yeah, what I would do would actually, I'd probably have 2 inputs. So you might have a double tap one for a second jump. What you might want to do rather than doing a double tap is have it so if you tap like that, you'll jump. And if you tap and hold, you'll get a little bit more air. So what you could do is basically while you're holding the button down, you'll add a little bit more velocity to the current velocity. Not nearly as much as this, but you'll kind of counteract gravity a little bit. That's actually a really good question. I'll sort of show you kind of how to get started with it. Assignment 1 in this class is going to be adding some features to our character movement. So that'd actually be a good thing to try and implement.
I also wanted to ask you, because we have a dodge in our game, and I wanted to have a dodge like if you double tap W, double tap A, S, D, like to do it in like different directions. And I didn't want to have like more key bindings in my input system. So I don't know.
A lot of games do that. I personally, just as a total person, I hate that so much in games.
I see.
I mash keys and I hit like a double tap and then I like throw myself off a cliff or something by accident. I'm not a big fan of that, but in the input manager, you can actually do that pretty easily. So I can show that.
Yeah, because right now I have it set to just 1. Like I think it's F right now, but it's more of a dash right now.
Right.
but I want it to be in different directions.
Yeah.
So.
Cool.
Won't the double jump just be Boolean that counts up? It's pretty easy. Like every time you touch the ground, it resets.
Oh yeah, so I mean it depends. Yeah, I guess if you wanted to do like a straight double jump, so you could like jump and then midair jump a second time. You could also add a counter alongside is grounded to figure out how many jumps you have remaining while you're in the air. So you could do that.
Okay.
Okay, so we have that hooked up. Let's go to our player controller because we need a way to call jump. So in our player controller, we'll set this up in the input manager when we get back from break, but we'll create a public void on jump function. And to get it to work, we have to take an input value parameter, but we're not going to care what it is. All we're going to do here is just take the onJump function, and we're going to call our character movement dot jump.
Were we supposed to add the jump to the input system?
No, it's almost 11, so we'll do that when we get back from break.
Yeah, just wanted to
I
check
think-
we didn't do it already.
Yeah, I don't think we added it yet. Actually, double check that really quick. No, we did not. Good. So we'll do that when we get back. Okay, so I'll leave this up. Actually, I'll leave the side by side. If you haven't played around with this, you can drag windows and VS Code to separate them or put them back together again. It's really cool. VS Code actually does this better than any other editor. Rider, surprisingly, I love basically in every way, except it does a terrible job of moving around windows. I don't know why. They just decided that wasn't super important.
There might be a setting for it though. I haven't deep dived enough to actually
So
find anything.
you
like
can
that.
do a split. So you have to right click and then go split and move right. Yeah, kind of like this. I just wish
Yeah.
you could drag them.
Yeah.
Okay, so it's 11 o'clock. Let's take a break for 10 minutes. And when we get back, we'll set up our jump from our player input. And we'll get the last piece of our movement going. Then we'll add in rotating our character, and then we're going to spend the rest of the class playing around setting up our animations. So we can get our character looking a little bit more lively than the weird T-pose moving around. Yeah, that was another thing in that tactics game I was watching. When one of his turns, he had his character like run past the enemy team as he ran by one of the enemies, which is standing there T-posing. It's a very buggy game.
Which game is this? Because I know Warhammer has an open license, so
Yeah.
anyone can build their first game out of it.
Yeah, let me look it up really quick. Avengers, Necromunda. Here we go.
This Necromunda? Oh, they've been
Yeah.
working on that for so long. It's too
Yeah.
bad. That looked really promising.
Yeah.
That's actually really tragic. I was hoping it was some nothing game, but nope.
No.
It'll be Necromunda.
Yeah.
That's too bad. That's such a cool topic, but whatever.
Okay, so what we're going to do next is set up our input to handle our jump, because everything is set up on the scripting side. We just need to make sure we're actually getting that jump message being sent from our player input. So I'm going to go to the player controller object that we set up in our scene last class, the one we were just plugging our character movement into. This time we're going to be looking at our player input component. So if you guys remember, we set up our player input here, and then we plug our standard inputs, an input action asset file, into the player input. And the standard inputs is what actually has our input settings in it. So if we go to our player input and just double click this, it's going to open up our input actions. So all we need to do is add a jump here. I also like to, just while I'm editing these, because I often forget to do it, there's an autosave checkbox up at the top that's going to autosave any changes we make as we make them. So I like to turn that on just so I don't forget to save something.
Sorry, which button do we press to access that?
To open this,
Oh, yes. Sorry.
go to your player controller and look at the player input component, then double click your inputs.
Ah,
It's file right here. It's
Thank
also just sitting in your, it's in your project. It's in the settings folder, this object here. You can also go to and hit edit or just double click it and it opens up. Okay, so we need to have a jump input. So we're going to go to the plus button where it says actions, the one at the very top, and click that to add a new action. So we can rename it. If we hit enter by accident, we can just hit F2 to rename it. We'll call it jump. So once we have our jump action set up, it currently has no inputs bound to it, so it's not going to do anything. So we need to add a binding. So now when we have jump selected, oh, right, by default, it'll give us one binding that's not hooked up. So we can click on it where it says no binding. And then we can add a binding to it. So the first one I'm going to set up is for the keyboard and mouse. So I'm going to check that off. And then on the drop down for path, we could go to the keyboard and find the space bar. I'm just going to hit the listen button, hit space, and then select the space button. If you want to add one for a controller, you can go and hit this little button where it says add binding. Select the top one, add binding, and do the same process with the controller. So I'll check off gamepad and then go to listen and hit my, whoops, see if I move the stick or hit anything, it's going to start adding everything to the list. Hit A, which is the button south on the controller, south, north, east, west. So we'll select button south. And now it also has gamepad support. And since we have autosave turned on, that's saved for us, should be ready to go. Now, if we wanted to do something like add a, for example, Karen's dash, we hit the plus button, add a dash, we can go in and add a maybe binding for the space bar. Not sure how you want to do it, but you can add the basically interactions and processors to certain things. So you can add them either to individual bindings. So we could have one specifically for the spacebar, or on the dash itself on interactions, I can hit plus. They actually have one for multi-tap. So you can have it listen for 2 taps, 3, 4, however many taps you want to trigger that input. And then of course it's set up to a dash input, so call the on dash function in our player input. I think if I leave that there and don't handle it, it might actually throw an error when I play. Let's see. No, it doesn't seem to care. I think if you have a function, show an example, our on jump here, it's going to expect that input value, even though we're not using the value for jump. I think it should get mad at me in the log. Oh, no, it doesn't seem to care. Okay, cool. Looks like they fixed that. That's handy. Okay, so once we have those inputs set up, we should be able to jump. The default setting 2 meters is pretty high, so that's jumping over 6 feet in the air. That's a pretty good vertical. I'm not sure if there are too many humans that can do that. So you might want to tune that value. One thing that's interesting to keep in mind is that since our character has a step height, I'll show you a quick example here. It's actually not a bad idea to add some cubes to your scene to test out different jump heights. So there's 1 meter, put one in for 1.5. 2 meters, see how that goes. This is something good to have in your gym while you're testing your game.
I just came back. Did
Oh.
I miss a lot?
You missed the setup of the input.
Did you talk about how to
I
double
did,
tap?
yes.
Oh, okay.
Okay, to go over it really quickly again, what we did.
Sure, I can also watch the recording.
Yeah. In the inputs, we just added a jump.
Yeah.
And then added a spacebar and gamepad button to it. I also added a dash just as an example.
Yeah.
The trick to get the kind of double tap stuff in here for something like a dash is you can add an interaction to the action. So you can hit that and go to multi-tap. Now it basically is going to listen for 2 taps within. You can customize this if you want, for basically how long you could hold the button down and how close it's expecting them to be together
Okay,
to get your dash input to fire.
I see.
Once you have the jump input set up, your character should be able to jump. So I can jump 2 meters high on my character because it's set to 2 meters right now. If I adjust it to something a little bit more realistic, maybe like my jump height is going to be 1. You'll notice I can actually kind of jump higher than that. So this is 1 meter, which I can jump onto pretty easily. I might be able to get 1.5. Yeah. So the reason for that is we have that step height on our character. So it's basically as I jump up, it thinks that this is a step, so it moves me onto it. So you kind of have to keep that in mind when you're jumping, particularly when using the character controller. The rigid body doesn't really happen as much.
Could we just disable our step height while we're
You could. The problem with that,
velocities?
if I duplicate this and make it really low,
We'll just while our velocities positive.
yeah, there's a few different ways you could kind of handle it. I just want to show as an example really quick. Make it 5. My step height is currently my step offset's 0.3. So if my platform here it's 0.5 high, I'm not going to be able to step up onto it. If I set it to half that, it's 0.25 high. Now on the floor, I can step onto it, which is kind of nice. Normally with a lot of character controllers, you'd bump into it and it would stop you from moving. This will kind of push me right on top of it, which is really nice for handling stairs and other small ledges without getting in the way of your character, which I really like. So I do like having a step height, and having too low a step height would honestly probably cause a lot of movement issues. So I wouldn't completely remove it, but you could lower it a little bit.
You could smooth out the camera from the cinema machine.
Yes. Yeah, if you wanted to add some smoothing from Cinemachine, we're going to talk more about Cinemachine on Friday, but
Yeah, just wanted to know if it's possible.
yeah. Oh, right. Yeah, we're not using Cinemachine. Yes, you can basically smooth out both your ability to look and the movement sticking to the character. So you could have it lerp a little bit. Particularly with 2D games, Cinemachine has some really cool features, so we'll go over those on Friday. Well, we've got jump working. Is jump not working for anyone? You're all good? Cool. So I think it's time we get this guy animated because he's looking kind of goofy right now, just hovering around T-posing. So first, let's get our rotation going. Now, one of the reasons I set up the camera the way we did, where our camera follows around our character, but it's not attached to our character, is if you were trying to use the character orientation to drive the character, and then you attach that camera to the character, you end up with some really weird behavior where the camera turns the player turns the camera, and then they kind of feed off each other, and you end up with all sorts of crazy movement. So what we can do now is we have our separate look direction coming from our player controller, so we can just use that value to determine the rotation of our character. So this will just take a couple lines of code here. This section down below, once we're done all of our movement under our rotation, we are going to figure out which direction our character needs to be facing. So I'm going to go quaternion, call this our target rotation. It's going to be quaternion, and we're going to use that look direction that we used before. Sorry, look rotation. So look rotation takes a direction and turns it into a rotation. So we already have our look direction. We are good to go there. Now we know the rotation we want to be facing, not what we're currently facing, but the one we want. The actual rotation, we're going to do a spherical linear interpolation, also known as a slurp. So we're going to go transform.rotation equals quaternion.slurp. So there's a quaternion.lerp. I don't know if I could find the image that shows the difference. Here we go. This is what I was looking for. So there's a lerp and a slurp with rotations. So slurp is supposed to be a little bit more expensive. I think you'd probably have to be doing like in the realm of tens of thousands of them per frame to even be able to measure a performance difference. But a linear interpolation on a rotation goes linearly from one point to another. So you'll get varying speeds depending on the relative direction of those two rotations. So if they're close together, kind of like this, it's nearly the same. If they are very far apart, so they're almost pointing in different directions, when you do a linear interpolation, you're going to end up in this kind of weird scenario where it's almost like you're moving faster through the center of the rotation and then it slows down near the end, because it's basically moving your rotation, if you can imagine, in a straight line between 2 points on a sphere. Spherical interpolation will move around the circumference of that sphere to move from one point to another. So you get a more realistic and more consistent change in rotation as you move from A to B, which is why I like to use this slurp. But both of them are very similar. They're called with the same parameters. They're basically interchangeable other than that slight difference. So quaternion.slurp, oops, spell it right, takes 3 parameters just like a normal lerp. We take an A point, a B point, and then a value telling it how much to move in between them. So our A point, our current, is our transform.rotation. Our B, our final rotation, is our target rotation. And our T value, our interpolation between the two, is going to be similar to our velocity lerp up here. We're going to take our time.delta time and multiply it by our turn speed. We could, rather than using a slurp, we could do a direct rotation, but I find that always looks weird on characters when they move at a very consistent rate from one rotation to another. It looks very strange and mechanical. If you do a slurp like this, the further you're looking from the direction you want to be looking, the faster you'll turn, and then you'll kind of slow down a bit as you reach your target rotation, which to me just kind of looks more natural and better than doing it at a fixed rate. Okay, so let's test this out. And my character is always going to rotate in the direction I'm facing. You can see there's a bit of that easing. If I do a quick 180, he moves fast at first and then slows down, which I like. If you want to make him rotate faster or slower, you can adjust that turn speed in the inspector here. So if I crank up my turn speed to like 20, whoops, stop playing. He's going to rotate much, much faster. Maybe 10 looks pretty good. Well, one thing we didn't play with either was our acceleration value. If I lower that to 1, it's going to take me a while to accelerate. When I try and stop, it's going to feel like I'm kind of on icy ground. So if you want to adjust the sort of feel of the surface your character's running on, you can mess around with your acceleration value. Okay, so the next step is getting some animations going on our character. So we're going to take a few of the values from our character movement, and we're going to use a animation controller script to feed them to our animator. So let's go and create a new animator. Right now our character, if we open it up, doesn't have an animator controller plugged into it, so we'll make one and then plug it in. So I'm going to go into the Assets, Art, Animations folder. And sure, I'll put it right in here. The basic shooter pack, I'll put my animator alongside all the animations. Oh, this is one thing that's worth noting, especially you guys are producing art assets for your team project right now. I would recommend always using this naming convention for your animations in Unity. So whatever the rig or character is, these are generic humanoid animations, so I just called it humanoid. But it could be, player at run, I don't know, whatever your enemies are called, blah, 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 at run kind of thing. What this does is it tells Unity that this is an animation file, and it automatically names the animation clip for you. So if we click on any of these and go to the animation tab, you'll see if we scroll down, they each have an animation clip. Some of them have multiple. This jump animation actually has a jump and a fall clip. It names them for you. If you don't do this, you have to import the file and then go into each one of these and manually, one at a time, edit the name and then scroll down and hit apply. Or else you're just going to have a whole bunch of animations called like clip 01, or whatever the default animation clip name is. So I'd always follow this naming convention when you import them. Once you import them, you could actually rename them to something else if you wanted to, but I just leave them like this. Okay, so in this folder, let's right click and create our animator controller. And I'm just going to call this humanoid rifle. Since all these animations are basically third-person shooter holding a rifle up style animations. And then I'm going to double-click it. So that's going to open up the animator window. Personally, yours might be closed. You open it. I like to dock mine beside the scene view here. Okay, so we played around with 2D animators before. We're going to play around with 3D animators now. And I believe we used a blend tree in Unity 1. We're going to use them again, but it's going to be a lot more obvious how powerful they are when we hook up some 3D animations. So first, let's set up some parameters we're going to use. We're going to have 3 parameters going into our controller here. I'm going to go over to the Parameters tab. It's going to open up on Layers, which we're going to ignore for now, and just go to Parameters. And we're going to create 3. We need one for basically our forwards and back movement. We need one for our left and right movement. And we also need a bool value telling us if the character is currently on the ground or not. Let's check something. Cool. Okay, so let's go in the parameters tab. I'm gonna go up to the plus button here, hit plus, and I'm gonna create a float. And I gotta be honest, I never know what to call these, Brian. I don't know if you have a convention you like. I often call them vertical and horizontal for moving forwards and back. Sometimes I know there's no really good word for me that represents the forwards and back. Like horizontal makes a lot of sense.
Yeah, I tend to use vertical and horizontal as well because I didn't think of things as an X and Y.
Yeah, vertical doesn't make a lot of sense because vertical is this way, not
No, and it's technically
this
Z,
way.
which should be full, which should be.
Yeah.
But what do you call it though? Like,
yeah. See, I don't have a good name for it. So if you guys want to use
I often will use I use rigid bodies, so
Mhm.
I tend to use velocity for a lot of these things as well.
Yeah.
So.
Okay. So I'm going to call these for now. I'm going to call it vertical and horizontal. So vertical is going to be our magnitude of movement forwards and back, and horizontal is going to be our magnitude of movement left and right.
You could call it Z input.
I guess.
I don't know.
This works for now.
Yeah.
So keep in mind these are float values. You should see a 0.0 beside them. And I'm also going to add a bool called is rounded.
It's the same animation for jumping and like falling.
We're going to have, yeah, one animation for jumping and falling, just to keep things simple. Then we're going to create a blend tree that's going to use these first two values, our vertical and our horizontal. So in the graph, I'm going to right click, go create state, and then go down to from new blend tree. And I always like to call this blend tree. I'm going to click on it and rename it to locomotion. This is where I'm doing all my moving. So you notice it's orange. This is because this blend tree is our default state. So when our character starts and our animator controller kicks in, it is going to use the locomotion state to start in. I'm going to double click it and open up our blend tree. So right now our blend tree is set to use one value. If we click on this here, we can edit the blend tree itself. So the blend type is currently one-dimensional. We want to switch it to a two-dimensional blend type. So we're going to use both vertical and horizontal. So I'm going to click on that, and then over in the inspector, you'll see this drop down that says blend type. There's a few different types, so you can click on that. And we have one-dimensional, we have three forms of 2D. And then we also have, actually, I don't think I've ever used direct. I think this might be, oh, so you can use this with an integer now. I think. Typically for blend trees, I use either one-dimensional or 2D freeform Cartesian. So the kind of differences are 2D simple allows you to have kind of like left, right, forwards, and back. The freeform gives you some additional options for kind of placing things, but these two modes don't like it when you have different magnitudes in the same direction. So you can't have like a forward, like walk, run, and sprint. The 2D freeform Cartesian mode is basically all bets are off. You can do whatever you want with the blend tree and create really complex stuff. So I usually use that one. The parameters right now are set to vertical and vertical, which we don't want. We want to change the drop down here. So it says horizontal and vertical. You can actually see them over here. For testing purposes, we can slide them around and play with them to preview what our animations are doing later on. And then we need a whole bunch of motions. So we're going to set up a idle, so we're standing still. We're going to have a run forward, a run to the right, a run back, and a run to the left. And then we also have, yes. And then the blend tree is going to interpolate between those. And we'll see it's better at interpolating certain motions than others. So we'll kind of see, it's going to look a little wonky in a couple of directions, but that's okay for now. So we're going to add more motions just by hitting this plus button down at the bottom of the list. And we're going to hit add motion field. And I'm going to do that 4 times. So we have 5 total motions. And then we're going to assign our motions to, assign our animations to these motions. So the first one, we need to hook up our idle. So I'm going to click the little picker button. And we'll see all of our animations here. So the first one is going to be idle aim. I'm going to select that one. And you'll actually see a preview pop up here with our character. If we hit play, we'll see our character in the blend tree doing his idle aim animation. I'm going to go through the rest. After idle aim, I'm going to add run forward, run back, run strafe right, and run strafe left. I have some additional animations in here for walking if you wanted to hook those up. We're not going to worry about it today. I don't know which one, Mixamo Duck. Oh, that's like the default from the character. Okay, we can ignore that one. Strafe left. Yeah, there we go. So we have idle aim, run forward, run back, strafe right, and strafe left. Now you'll see we can click on them. Click here, we can actually see, this is basically the center of our graph, and these are the positions where each animation is on our graph here. We want to move these into sort of a position that makes sense. So run forward should have a value of 0 on X and 1 on Y. It's going to be our moving forward. You think about this as a 2D graph where this direction is running forward, this is running back, then we have running to the right and running to the left. Run back should be the opposite. So it's going to be 0 on X and -1 on Y. Run strafe right is going to have 1 on X, so we're moving to the right, and 0 on Y. Whoops. And run strafe left is going to be the opposite of that, so -1 on X and 0 on Y. So we have our idle animation directly in the center of our little graph, and then our 4 movement directions surrounding it. You could have a lot of different animations in here. You could have your walk animations kind of halfway in between the idle and the run. You could also have corner animations as well. So you could add a lot to this blend tree to make your really kind of specialize all of your animations. If you want to test this, you can actually grab this red little dot and move it around. So when I'm here, you can see it actually shows the animations and how much weight each one has. So I can move from idle to our run, our strafe right, run back, which looks kind of goofy, and our strafe left. You'll notice those directions look okay. Those are direct animations. Looks a little bit goofy in some directions. If we actually go forward and right, it's not bad. Back and right looks a little weird. Back and left, he's kind of do some funny footwork, but it's not terrible. I think forwards and left looks super weird. It looks injured or something. So it's not going to do a perfect job interpolating between the different animations, but it's good enough for our prototype right now. So what we need to do, so you can actually see as we drag this around, if you look on the left-hand side, you can see our horizontal and vertical values changing. So we need to feed these values correctly into this animator to get our character animating in the correct direction. So we can create a script that will read values from our character movement and send them to the animator. Let's go to our scripts. And I'm going to create a new script called the animation controller. Now, even though we're feeding values directly from our character movement over to the animator, I like to create this as a separate script so we can reuse it in a generic sense. So we could have some other animator hooked up, might not even necessarily be a humanoid, but if, as long as we send very generic values, like, you know, moving forward, moving left and right, whether or not we're grounded, we can let the animator determine how those animations are going to be playing and not have to worry about the code side changing the code for each character and how they're animating. So let's open up that animation controller, and this is going to be pretty simple. So first, we need access to the relevant components. The first is going to be our character movement. The second is going to be our animator. Now I'm exposing both of these because this is one of those scenarios, like I mentioned, where I'm not 100% sure exactly where I want to have this component sitting. And this allows us to either put the animation controller on the character with the animations itself, or leave it on the root body. It's kind of up to us. And we're going to send all of our values just in the update function here. So just like our 2D stuff that we did before with our animator, it's the exact same process, sending values from our code side to our animator. So we're going to send all of our values going animator.setFloat. First, we'll set our vertical. And this is going to be our character movement dot local move input dot Z. We also need to send our horizontal movement. Remember that these are written as a string, so they need to be exactly the same way you've written them in your animator. Same spelling, same capitalization. The third value is a bool. We're not using it yet, but we might as well write it here. This will be our is grounded. So we're sending all three values to our animator, and that isn't our entire animation controller script. We're letting the animator decide pretty much all of the behavior on the animation side of things, so we don't have to do a whole lot on the code side. And I'm going to open up character movement on the side here because I realized we did miss one step here in the character movement. So the local move input, we're never setting that. So right now it's going to be 0, or our character is just going to sit in the idle animation if we try and use this right now. So on local move input, we need to set that. We can do it when we set our move input, except we need it to be relative to our character's orientation, like I talked about before. If our move direction is north, but we are looking, say, east, we obviously need to be sidestepping left rather than trying to run forward because we're not actually looking north. So there's a really simple function that'll actually take care of this for us on the Unity side. We can go from local to, sorry, from world to local input and back and forth using a couple different functions. So after we set our normal move input, I'm going to set my local move input by going local move input equals transform dot inverse transform direction. Hopefully I'll get a tooltip here. There we go. So I always double check this because I get them mixed up constantly. So there's an inverse transform direction and there's also a transform direction. And like I said, I get them mixed up constantly, so I always double check when I'm using them. Inverse transform direction goes from world to local space. Transform direction goes from local back to world space. So it goes in the opposite direction. Well, we want to go from world to local space because our current move input is telling our character which direction in world space they need to move. All we need to pass is our move input. This is one of those scenarios where you could do a bunch of math to figure it out yourself or use this handy function. Okay, so let's go and test this out. We obviously need to hook up our animation controller first. As I mentioned, this is kind of up to you guys where you want to put this. A lot of the time I'll end up putting animation stuff beside the animator itself, but it could also sit on the root character. Oops, sorry, punch my microphone. I'll put it here for now. This will be our animation controller. All we have to do is plug in our character movement and then our animator, which is attached to our Y-bot.
Actually, I have a red line is grounded in the update.
On your animation controller?
Yeah, that part.
Mouse over it, what does it say?
Name is grounded, is not exclusive.
Is it spelled correctly?
Yeah, I copy and paste it.
Is it public in your character movement?
Let me check. Public or is grounded. Yes.
So it looks exactly like this?
Yes.
Can you share your screen? Oh, wait, I might not have, sorry, one second.
Yeah, I think you have to enable it.
Yeah. Okay, you should be able to share now.
It's grounded, the same.
Yeah, so let's see your animation controller.
Oh, you use the comma, not a dot.
Oh yeah, you need a period. Yeah,
There you go.
there you go, perfect. And yeah, there you go. So now you can plug in your character movement.
Right here?
Yeah, into your character movement spot. And then, oh, click on your character again. Then you need to plug in the animator. So drag the Y-bot, yeah, onto the animator. Yeah, there you go. So now we can test this out. Oh, yeah, I forgot a step. So if we hit play now, he's still going to T-pose, and we're getting a bunch of spam in our console here saying our animator is not playing an animator controller. So I forgot to plug that in. So on our Y-bot, we need to make sure that our controller here, we can use the little picker button to make it easy, is pointing to our humanoid rifle. And we're forgetting one step that I'm going to show you guys. We're going to notice a weird bug when we play. We get that set up. I'm going to move, and my character's going to run off the screen. Bye-bye. He's actually going to go right through geo and walls. So the reason why this is happening is because we have an option called root motion turned on. So if you want to be super fancy and have, it's actually pretty good for cinematics. If you want a character to move from A to B, just using the animation itself, you can leave root motion on. And if the animator has a velocity on his character, in the animation, it'll actually move around the scene. For character movement, I really hate it. You can hook it up in games. You can actually read the velocity from the animation and put that back into your character velocity to move your character around. But to me, it feels really bad most of the time. I remember the first Witcher 3 released with that turned on. And I remember trying to grab like some food off of a barrel. And since the movement was tied directly to the animation, you couldn't rotate without moving. So you'd move forward and then try and rotate. And you would like take a step forward and then turn right slightly. And I remember just spending like 30 seconds walking in a circle around this barrel because I couldn't just turn to face the barrel to pick the food up off of it. They eventually actually added an option to basically remove it, and the character movement felt way, way better. So I'm usually against that in terms of gameplay, just feel. To disable it, we can just go onto our Ybot and uncheck apply root motion. And now our character is going to move around with our character controller without moving off of it. So you notice a few issues. Running forwards and back looks pretty good. Character's a little slidey. We could adjust our acceleration to deal with that. The angles look a little bit goofy, but we're not going to worry about that. The big issue is how quickly the character snaps from one animation to another. You can see it's almost like instantaneous, and he's doing like a little dance if I keep changing directions. It looks pretty weird. So we can actually fix that through code very easily. If you do this live, you can watch the values. It might be really hard to see here. You can watch the values as they're entered into my animator. Watch them just whip around instantaneously. There's no easing or anything going on there. So we can actually tell the animator to enable some easings to avoid that. So I always add this to my animator controllers. There's a value, and it can just be very small, called a damp time. So I'm going to create a new float. I'm going to set it to 0.1. I usually either go with like 0.1 or 0.05, something very small. And we can add this as a second parameter to our animator. So after our move input here, it takes, it takes two parameters. They separate it for some reason, but we feed it a damp time and then our delta time. So this only works on setting floats. There's no sort of lerping or interpolating bools. They're on or off. Same thing with integers. Once we have that added, do the same thing, and you'll see there's a bit of easing going on. So now it's a little bit more smooth. The animations will kind of lag behind a little bit because they're not instantaneous, but it's going to make the animations look a lot more smooth and natural rather than snapping back and forth between them immediately. Now that my animations are in, it definitely looks a little bit slidey. So we can adjust the speed of our character and our acceleration on our character movement here to kind of help with that. So if I crank up the acceleration to maybe 10, yeah, there we go. Feels pretty good. The move speed actually isn't bad. One thing we're missing, we've kind of run out of time for today. We'll get it done first thing next class before we start working on AI. is the jump. We just stand still when we jump up in the air, but we'll get that added, so we'll actually go into a little jump animation. But it's looking a lot better than it did at the start of class. Oh, we're also missing a weapon. So there's a weapon mesh that we'll add to our character's hands too. And I'll show you the kind of goofy trick I have for adding prefabs and stuff to characters. It can be kind of hard with adding a weapon to a bone and getting it rotated correctly. So I do it while the game's running, copy the values, and then apply it to the prefab afterwards. So we'll go through that process to actually get the rifle sitting in the character's hands. So we'll wrap up for today. I'll stick around for any questions. I also wanted to bug you guys. So we're gonna do the team project presentations first thing tomorrow morning. They're not like full on, you don't need slides or anything like that. You're just showing us what your progress is so far. Again, if it's on multiple computers, if someone's doing art, someone's doing code, someone's got some design stuff they want to show, that's totally fine. We can hop around and check it all out. After that, I have a bit of stuff I want to cover with you guys, but I also want to make sure that you guys feel like the specific needs of your projects are being addressed in our team project class time. So I want to give you guys a bit of time to work on your own. But if you guys have anything specific you want me to cover, I can go over it with you guys in team project. I know I believe Jordan messaged me over the weekend asking about playing around with some kind of color changing stuff, working on desaturation for cognition. So I can show you guys how to do that overall with some post-processing. We'll play around with that. Oh, sorry. Okay, it stopped. All right, sorry about that. So I'll show you a bit of that tomorrow. We're gonna go more in depth into post-processing. I think the third class probably, or maybe fourth class of our Unity tools. So we're not gonna go crazy in depth tomorrow, but I can show you guys how to do some desaturation type stuff. But if you have any topics you wanna cover, please write them down and bring them up during class tomorrow. We can go over them. Oh my God.
Yes, it's time.
Yeah, I think it's time to wrap up class before I
but
get you guys deaf.
I have a
Okay.
quick question about
Yeah,
like
I'm gonna stop recording so this stuff isn't in that.
it was more like